Right, ready to dive into something sweet?
Oh yeah, bring on the sugar rush.
But this isn't just about satisfying your sweet tooth. We're going full-on science nerd today, uncovering the chemistry that makes sugar so fascinating.
Most people just think about the taste, right? But there's a whole world of molecules and reactions happening behind the scenes. It's pretty amazing.
Okay, so we're taking a deep dive into this sweetness and structure of sugar. They break it down into 5 main points, starting with Sugar Chemistry 101, the basics, sucrose, fructose, glucose, and all those carbs.
Exactly, like breaking down your favorite dessert, but on a molecular level.
First up, they tackle sucrose, good old table sugar. But here's a twist. It's not a solo act. It's a disaccharide, so it's a dynamic duo of, what was it, glucose and fructose.
You got it, and that's what makes it so versatile in recipes.
And then they get into the science behind why sugar actually tastes sweet.
It's all about how those molecules interact with our taste buds. It's pretty cool.
Wait, so there are specific receptors on our tongues for sweetness?
Yep, like microscopic locks, and the sugar molecules are the keys.
Huh, that's incredible. It's like a molecular puzzle where the taste depends on the shake. And then, of course, they break down caramelization, how heat transforms sugar.
And it's not just about the color change, it creates new flavors.
It's like kitchen alchemy. You start with white sugar and end up with this depth of flavor. And their last point, this is interesting, sugar isn't just about sweetness, it's structural too.
Exactly. It plays a key role in the texture of food, that satisfying crunch or that melt-in-your-mouth smoothness. Think of sugar molecules like tiny architects.
Wow, this is making me rethink my whole relationship with sugar. But where do we even begin with all this?
Let's start with those basic building blocks: glucose, fructose, sucrose.
Okay, let's get molecular. First up, glucose. Now, this one sounds familiar. Isn't that what our bodies use for energy?
Right, it's often called blow sugar because it's what fuels our cells.
So that's the energy rush after a sugary treat.
Yeah, basically mainlining glucose. Now, fructose, you find that naturally in fruits, honey. It's actually much sweeter than glucose.
That's why a ripe mango can taste so intensely sweet, even more than a cookie with the same amount of sugar.
Exactly. It's the fructose. It has a shape that just fits those sweetness receptors perfectly.
So glucose, the energy workhorse, fructose, the sweetness champ. And where does sucrose, table sugar, fit into all of this?
Remember, sucrose is that power couple, glucose and fructose, bonded together. That's why it's so versatile. It delivers both the quick energy and the intense sweetness.
So it's like the best of both worlds, probably why it's such a staple in kitchens everywhere. So if sucrose is already made of glucose and fructose, does that mean it's less sweet than pure fructose?
That's a great question. And yes, pure fructose is actually sweeter.
Interesting. So that's why recipes sometimes call for specific types of sugar. They're fine-tuning the sweetness level.
Exactly. Chefs and bakers know this. Different sugars have different sweetness profiles.
This is making me look at my sugar bowl in a whole new light. But we can't forget the other players, the carbohydrates. Where do they fit in?
Carbohydrates, think of them as the extended family of sugars. They're long chains of sugar molecules linked together. They give our bodies sustained energy.
So that's why things like bread and pasta give us longer-lasting energy than a candy bar.
Exactly. Those long chains take longer to break down.
Okay, so we've got our sugar players identified. Glucose, the energy workhorse, fructose, the sweetness champion, sucrose, the versatile duo, and carbohydrates, the long-distance runners of the energy world. But how do we actually measure how sweet something is? Is there like a sweetness scale?
There is. It's called the sweetness index. They use sucrose as the benchmark, give it an index of 1. Then you compare other sugars to that.
So fructose would have a higher index since it's sweeter, right? What about honey or maple syrup? Where do they fall on this sweetness scale?
Honey, high fructose content, comes in around 1.7. Maple syrup can vary, usually sits between 0.6 and 0.9, depending on the type.
Wow, so there's a whole range of sweetness out there. Knowing this could help us make better choices about what we eat. Does this sweetness index only apply to natural sugars, or are artificial sweeteners in there too?
Great question. Artificial sweeteners are actually off the charts. Aspartame, for example, has a sweetness index of about 200.
200, that's incredibly sweet. No wonder they use such tiny amounts. So knowing all this, different sugars, different sweetness levels, that opens up a whole new world in the kitchen, doesn't it?
Absolutely. It lets you really fine-tune the sweetness and experiment with flavors.
I'm feeling inspired to get creative. But before I grab my whisk and sugar bowl, let's recap. What have we learned so far about this surprisingly complex world of sugar?
We started with the basics, right? Glucose, fructose, sucrose, carbohydrates. We learned that sucrose, table sugar, is a dynamic duo of glucose and fructose.
Yeah, giving it that perfect balance of energy and sweetness. We also learned that sweet taste isn't magic, it's chemistry. Those sugar molecules are fitting into receptors on our tongues. And the better the fit, the sweeter it tastes.
We even uncovered the sweetness index. Different sugars, different sweetness levels opens up a whole new world of possibilities in the kitchen, and we're just getting started. There's still so much more to learn about sugar.
I can't wait, but I think that's a good place to pause for now. Let all this sweetness sink in a bit.
Take a break, grab your favorite sugary treat, and think about all that chemistry we just talked about.
And be sure to join us for part 2, where we'll delve into the magic of caramelization and explore how sugar creates those textures we all crave.
Welcome back to our sugar journey.
Okay, I am ready to crank up the heat because we're about to explore caramelization, that magical transformation, sugar turning into this golden brown symphony of flavor.
Yeah, it's a process that has captivated, chefs, home cooks for centuries. And it all comes down to chemistry, how heat affects sugar molecules.
So in part 1, we talked about those basic building blocks, glucose, fructose, and sucrose. But now things are getting a little toasty, so what's actually happening to those sugars when we apply heat?
Well, when you heat sugar, those molecules, they start to break down and rearrange. And that creates a whole cascade of new compounds. And that's what gives caramel its color, its flavor.
So it's like a molecular dance party fueled by heat.
I like that. And as those molecules break down and recombine, they create hundreds of new compounds that contribute to that aroma, that taste we love about caramel.
It really is like alchemy in the kitchen. You start with this plain white sugar, and with a little heat, you create this depth of flavor and gorgeous amber color.
Exactly. And here's where it gets even more interesting. The type of sugar you use can actually influence the final flavor.
Wait, so different sugars create different caramels? I thought caramel was just caramel.
That's a common misconception. For example, caramelized glucose, that tends to have a more delicate honey-like flavor, while caramelized fructose can be much more intense and almost fruity.
Wow, I had no idea. Suddenly I'm seeing a whole new world of flavor possibilities.
It all comes back to those molecular structures we talked about earlier. Different sugars, they have different arrangements of atoms, which means they break down and recombine in unique ways when heated.
So each sugar has its own signature dance move on that molecular dance floor, creating a unique flavor.
I love that analogy, and that's what makes caramelization so fascinating. It's a delicate dance between the heat, the time, and that unique chemistry of each sugar.
This is making me want to experiment, but before I grab my saucepan and blowtorch, I have to ask, is caramelization just about flavor and color, or does it affect the texture too?
That's a great question. It leads us right into the other fascinating aspect of sugar we wanted to talk about, its structural role in baking and candy making.
So sugar isn't just a flavor enhancer, it's like a master architect in the kitchen. Pretty impressive for something so tiny.
Exactly. Sugar plays a crucial role in providing texture, structure to all sorts of things, baked goods, candies. It all comes down to how those sugar molecules interact with other ingredients.
Okay, break it down for me. How does sugar actually create structure in food?
You can think of sugar molecules as tiny building blocks. They're capable of forming bonds with other molecules like water, proteins, fats.
So it's like the glue that holds everything together and gives it that nice bite.
That's it. For example, in cookies, sugar helps to create that crispy, crunchy texture.
And in candies, it gives it that smooth, melt-in-your-mouth quality.
You got it. And here's where it gets even more interesting. The type of sugar you use can actually influence the final texture.
Wait, so different sugars can change the texture of my baked goods. I always thought a cup of sugar was a cup of sugar.
Not quite. For instance, sucrose, that's known for creating a crisp texture, while glucose can contribute to a softer, chewier texture.
Mind blown. Baking really is a delicate balancing act of chemistry, and sugar is one of the key players.
It absolutely is. Understanding the structural role of sugar can really empower you in the kitchen. You can experiment with different types of sugars and see how they affect the texture of your creations.
Makes me want to try something new. But let's zoom out for a second. We've talked a lot about cooking, but what about sugar's impact on our health?
Ah, yes, that's a big one. And, it's a topic that generates a lot of debate, a lot of confusion. Sugar has a complex relationship with our health. It's not as simple as saying it's good or bad.
We've all heard those warnings about eating too much sugar. But isn't sugar also a natural part of a lot of healthy foods like fruits and vegetables?
Absolutely. Sugar is found naturally in tons of things, fruits, vegetables, even grains. And those naturally occurring sugars, they're often packaged with fiber and other nutrients that moderate their absorption and impact on our blood sugar.
So it's not the sugar itself that's the problem, but the way we consume it.
That's a key point. When we eat large amounts of processed sugar, especially those added to foods and drinks, that's when you see a rapid spike in blood sugar levels.
And those spikes can have a pretty big impact on our health over time, right?
Exactly. Consistently high blood sugar can increase the risk of things like type 2 diabetes, heart disease, even certain types of cancer.
That's why it's so important to pay attention to how much sugar we're eating, especially all that added sugar that sneaks into processed foods.
Absolutely. Reading food labels carefully, being aware of all the different names sugar hides under, that's crucial for making a good choices about what you eat.
Like a defective game at the grocery store.
I like that. You have to be on the lookout for all those sneaky aliases sugar uses.
Yeah, but while it's important to cut back on added sugar, it's also important to remember that sugar isn't inherently bad.
Exactly. It's about balance, like with most things.
Right. So we've talked about the downsides of too much sugar, but what about the good side? Are there any benefits to eating sugar?
Of course. I mean, sugar gives us energy, which we need for everything. It also plays a role in brain function and can even improve mood sometimes.
Yeah, I've definitely experienced that sugar rush before. Sometimes a little piece of dark chocolate can be just what I need.
And let's not forget the cultural and social significance of sugar. Sweet treats, they're often associated with celebrations, holidays, special occasions.
That's so true. Birthday cakes, holiday cookies, it's a way of bringing people together, creating those happy memories.
It's a good reminder that food is about more than just fuel. It's about connection, tradition, enjoyment.
This has been a really helpful conversation. I appreciate that balanced perspective. But I'm curious, beyond health, are there any other fascinating facts about sugar that might surprise people?
Well, one thing that I find fascinating is that sugar has a really long history, going back thousands of years.
Really? That's interesting. Where did sugar even come from originally?
Sugarcane, that's where we get sucrose from. It's believed to have originated in New Guinea.
Wow, that's a long way from my kitchen. How did it make its way to the rest of the world?
It's a long story, a tale of exploration, trade, even conquest. Sugarcane cultivation, it spread throughout Asia, and then eventually reached Europe through Arab traders.
So sugar was a hot commodity even way back then.
Oh yeah, it was a luxury good, often reserved for the wealthy.
I can't even imagine a time when sugar was rare. It's everywhere now.
It's amazing how sugar has gone from a luxury to a common ingredient in everything we eat.
Speaking of the modern world, I've heard a lot about sugar alternatives. Are those a healthier choice?
That's a tough one. There are so many different sugar alternatives out there. Each one has its pros and cons.
Like, what are some of the most common ones?
Well, you've got artificial sweeteners like aspartame and sucralose, sugar alcohols like xylitol and erythritol, and then natural sweeteners like stevia and monk fruit extract.
That's a lot to choose from. How do we know which ones are best?
It's important to do your research, consider what you need, what you like. Artificial sweeteners, for example, they can be super sweet, but there have been some health concerns about them.
I've heard that. What about sugar alcohols?
Sugar alcohols, generally, they have less of an impact on blood sugar than regular sugar, but some people, they get digestive problems if they eat too much.
So moderation is key even with these alternatives.
Absolutely. And then there are the natural sweeteners, stevia, monk fruit, those are derived from plants.
Those sound promising. Any downsides?
Well, some people find that stevia and monk fruit have a kind of bitter aftertaste.
So it comes down to finding what works best for you.
Exactly. And it's always a good idea to talk to a doctor or a dietitian if you have any concerns or special dietary needs.
This has been such a fascinating conversation. We've gone from basic chemistry to sugar's role in our health, even its history. It's amazing.
It's remarkable how much there is to learn about this one ingredient.
I'm seeing sugar in a whole new light. But before we wrap up this part, any final thoughts?
Well, just remember that sugar is one piece of the puzzle when it comes to a healthy, happy diet. Focus on eating a variety of whole foods, fruits, vegetables, lean proteins, whole grains. That's what matters most for well-being.
That's a great point. And then, with most things in life, balance and moderation are key.
Well said. As we finish this part of our deep dive into sugar, remember to savor every bite of your next sweet treat. Think about all the intricate chemistry and history we've talked about.
I will. And be sure to join us for the final part of our deep dive, where we'll uncover even more surprising secrets about sugar, its role in things like materials science, its impact on art and culture. Back for the final chapter of our sugar saga. I'm a little sad to see it end. Who knew sugar could be so fascinating?
It has been fun exploring all the different sides of sugar, the molecules, the taste, the history. But we saved some of the most surprising stuff for last.
Oh, you've got me curious now. What sugar secrets are we about to uncover?
Get ready for this. We're stepping outside the kitchen. We're going to see how sugar is being used in, get this, materials science.
Wait, sugar and materials science? I thought we were talking about desserts, not building materials.
I know, right? But believe it or not, sugar is becoming a key ingredient in making sustainable and biodegradable materials. It's all about using those tiny sugar molecules to create something totally new.
Okay, you've got my attention. How are they using sugar to make new materials? It's like some kind of sugary glue.
It's a bit more complicated than that, but you're thinking along the right lines. Scientists are figuring out how to transform sugar into building blocks for things like bioplastics, packaging materials, even stuff for construction.
So instead of using those petroleum-based plastics that takes forever to break down, We could be using sugar-based alternatives that are renewable and biodegradable. That's amazing.
Exactly. Sugar is abundant, it's renewable, it's got huge potential for creating a more sustainable future. It's like turning candy into a solution for the environment.
I'm picturing a future where we're drinking from sugar cups and carrying our groceries in sugar bags. It sounds almost too good to be true.
It might sound futuristic, but those innovations are closer than you think. Scientists are making big progress. It shows how creative they are and how versatile this simple ingredient is.
This is changing how I think about sugar. It's not just something sweet. It could change the world. But before we go too far into the future, what about sugar in art and culture?
Good point. Sugar has been inspiring artists and shaping cultures for centuries. It goes way beyond food. You see it in art, sculptures, all sorts of creative things.
I've always loved those sugar sculptures, the ones that look like glass, but you can eat them. How do they even make those intricate designs with sugar?
Sugar art is a real skill. It combines cooking with artistic talent. They carefully heat and work the sugar until it's flexible. Then they can mold it, shape it, even blow it into amazing shapes.
It's like edible architecture. And sugar is also a big part of traditions and ceremonies around the world, right?
Absolutely. Think about wedding cakes, Day of the Dead sugar skulls. Sugar marks special occasions, represents beliefs, tells stories through food.
It reminds us that food isn't just fuel, it's art, traditions, stories, connection to our culture. Are there any stories, like books or poems, inspired by sugar?
Well, one classic that comes to mind is Charlie and the Chocolate Factory. It's a whimsical story, captures the magic of sugar and candy.
Ah, Willy Wonka's Chocolate Factory. It's pure imagination, all fueled by sugar. And we can't forget all the cookbooks dedicated to baking and making candy. Sugar is a literary star.
It really has influenced creativity and expression in so many ways. From inspiring artists to shaping traditions, sugar is woven into our lives.
This deep dive has been incredible. We've covered so much: the chemistry, health, sustainability, art, culture, even the future. I have a whole new appreciation for sugar.
It's been a pleasure sharing this sweet journey with you. We hope our listeners have learned something new about sugar, how complex it is, how versatile, and how much it impacts our world.
And to everyone listening, thank you for joining us on this deep dive into sugar. Until next time, may your lives be filled with sweetness and wonder.